We'll begin by doing a preview of what we will be building. So we're going to be building a gossip middleware that allows us to do a shared state. We're going to start a node on port 3000 and it receives a callback. So let's just do io.inspect for now and start a second node on port 3001 and a third node on port 3002. So we have node A, node B, and node C. Let's connect them together. Let's connect node B to localhost port 3000. So connect node B to A, and we're connecting node C to A as well. So node B and node C are not connected to each other, but they have a common neighbor. Now we can broadcast from node B, and we're going to say hello. And we have two hellos on the output. This is because node B contacted node A, which relayed the message to its neighbors. Now we can also broadcast other data structures and more complex ones. Let's do a map. And we get this representation. So this allows us to do a shared state across all nodes. And this is a preview of what we're going to do. We'll begin by creating a new Mix project. So Mix new gossip, cd into that, and let's open the gossip file and remove everything on the inside. We'll define a start function that receives a port, but let's also give it a default port for now. Set that default port to 3000. And the first thing we want to do is to get a server socket. And we can do that through gentcp.listen, give it a port, and give it some socket options. Now these socket options start with either binary or packet. Packet means the content is delivered as a list, while binary means it's delivered as binary. So let's use that. Let's also set packet to 0, which means no packaging. Let's set active to true. And if we had false here, we would have to explicitly call gentcp.receive, which is a blocking operation. Instead, we can just set active to true. And the system will send us messages whenever someone writes to the socket or whenever the socket is closed. So we can have a receive block and pattern match on that. Finally, we also want to do reuse address to true, so we can reuse port numbers. And after having a server socket, let's accept a new client through gentcp.accept, give it the server socket, and whenever a client connects, let's just send the shrug guy to it. Now this shrug guy, I have a command for it because I really like to annoy my coworkers on Slack. We're going to need to do a new line, escape that character there, and let's do IEX. Okay, we started our process and it's blocked because gentcp.accept is a blocking operation. So let's do netcat, and we got the shrug guy back. Now the next step is to actually handle that client, and we're going to handle that through a receive loop function. And we'll define that here, receive that socket. And like I said before, the system is going to send some messages to us. Whenever a client disconnects, we're going to get the TCP close message, and we want to close the socket in that case. We also are going to get the TCP message whenever a client writes to the socket. So let's just do received content, and also send that shrug guy back. Finally, if we get a message that we're not expecting, let's just inspect it and launch IEX. Again, let's start gossip and do netcat. Now we'll say hello, and we get the shrug guy back. So all we're missing is the loop. And I'm going to loop by doing and receive loop, do this recursive call. But I only want to do the recursive call if we receive a new message or a message that we're not expecting. If the client has disconnected, let's just return false. And get rid of everything and restart. So we started our gossip. and we connected. We're going to say hello, and we get the shrug guy back. Now I say hi there, we still get the shrug guy, and we disconnected, the loop has ended. The problem is that there is no remaining connection, so if we do netcat again, nothing is happening. This is because we're only accepting one client, so instead of doing the receive loop, let's also do an accept loop and pass that server socket along. So now we can do accept loop and get the server socket. We're going to accept a new client, we're going to receive messages from that client, interact with it, and then we're going to recursively call accept loop. Okay, formatter has run. Let's restart and do gossip.start there. Go with netcat, say hello, and we get the shrug guy back. We disconnect, we connect again, say hi, and get the shrug guy again. But we're still not handling concurrent requests, so we will need to fix that. Our next step will then be to create a server module. So let's do that. Let's split this and define gossip.server. This will be a task, so we can do start link, receive a list of arguments, and call task.startLink with the current module. Let's just call the run function and pass the args along. Now we can pretty much take code from here and replace this start for run, get rid of that default port. We'll need these two lines here, so this, and for now I think it's pretty much it. Now what we want is to change this start function to do supervisor that's start link and give it a list of children to start, so it will be our server with the port, and as a strategy let's just do 1 for 1. Okay, so we need to write our server, and here we go. Let's do gossip.start, and this is the process ID of that server. Let's do netcat now for 3000, say hello, and we get that shrug guy, and here's the hello message, and we can keep writing and everything keeps working. So this is looking good so far, but we want to handle multiple clients connecting, so let's just create a worker module instead. Now this worker module is going to contain most of the code of that receive loop from the server. It will also be a task, so let's use task, but instead of using start link, let's define start with a list of arguments and call task.start, current module, it's called the receive loop function, pass the arguments along. Now we can just grab the receive loop from here and let's make this function private. Write this down, and instead of doing receive loop, let's do gossip.worker.start and pass the socket. Let's try it out. Now we're going to need that shrug guy on the other side, so let's move it here. Okay, let's do gossip.start. That's our server running. Let's do netcat and write hello, but we get nothing back. And we get nothing back because when we start our worker, the server process is the one that owns the socket, and then it passes it along to a new process. When this process attempts to write to it, it's not going to work, it's going to error out. So we need to do gentcp.controlling process and give the control to the new worker. So to get the process ID of the worker, let's just pattern match with okay PID, and we'll try that. Let's do gossip.start. Let's launch netcat and say hello, and now we get the shrug guy. And if we launch another concurrent client, we also get the shrug guy, and we can work with both. Okay, let's clear everything. Okay, so our next step is going to be to add connections in our Gossip module. If you remember the demo, we had a connect to function that attempted to connect to an existing server. So our best bet is to do that now, and let's do it here. Let's do connect to receive a host and a port, and we can use GenGCP to connect, and let's do connect to host, port, and pass an empty list of options. And these are the equivalent to the socket options on our server. So let's just use defaults for now. Now, if we were able to connect, let's write to that socket and send it hello there. If there was some sort of error, then let's just return the error. Okay. So we can do gossip.start now. We got the server process ID. Let's do gossip.connect to localhost and the port, and we received hello there. Okay, this is good and all. We can create a server, we can connect to it, but we wanted to create multiple instances of the Gossip module. And to do that, we're going to need a gen server. The main reason for the gen server is that we need to keep state. So we need to know which neighbors we have and what messages we have received or haven't received. So let's start by doing use gen server here. Let's change this function to be sort link, and it will receive that port and default port. And let's just do gen server.start link current module. Let's give port to our init function and an empty list of arguments. Now we'll define that init function and header match on the port. Now let's just clear this right away. We're going to do start server here and move this function down here, because when we do init, we want to save the process ID of that server. So we can just use start server with the port. Now for our default state, let's save the port, save the server ID, and return OK state. Finally, we're also going to need to handle this function, the connect to. Let's define it up here, and we'll receive a PID, a host, and a port, and do genserver.call connect to host and port, and we're missing the PID here. Now let's change the connect to function to be a handle call. Let's surround this and pair match on connect. And now we're going to receive a certain state. Okay, like I said, we want to save the list of neighbors. So let's add that to our default state. And when we connect, we're going to add that socket to a list of neighbors. So our new list will be socket and append it to state neighbors. We're still going to send that hello there, but now we need to reply something here. We need to return reply, certain reply, new state, and we're going to get both of these variables from here. So reply new state equals case. Let's just format this. And now what we are going to do is return OK, and update our state. So neighbors, and here let's just return the error and the current state. So we should be able to connect two nodes now. Our next step will be to broadcast from one node to the other. We can do that by adding the broadcast function, which receives a process ID and a message. And let's do genserver.cast, process ID, message, broadcast message. And let's go down here. We'll need to do a handle cast match on that broadcast and that message. And we'll also pattern match on our state. Now what we're going to do is to iterate over our neighbors. And for each neighbor, we'll do gentcp.send to our neighbor, that message, and return no reply state because we're not updating anything in our state. I think this is good to be tested, so let's do that. Okay, we're going to start node A on port 3000, and we're going to start node B on port 3001. Let's connect them together through the connect to function and connect node B to localhost 3000. Oh, so something blew up. And this is because I'm not matching on the correct handle call message. So here it is. Let's just clear that. Do this. Let's do everything again. Well, we received a hello there because we connected and sent hello there, but we also had this unexpected message. This is because when we connect, remember our worker was sending that shrug guy. So when we connect, we get some defaults given to that socket, and one of the defaults is setting the active mode to true, which means that our process will receive a message whenever someone writes, and the worker on node A is writing the shrug guy. So our gen server is receiving a TCP port and then the content as a message. And instead of handling that through a handle info, let's just do active false and redo the whole thing. So create node A, node B, and connect to, and we'll also broadcast from node B to node A with hello, and node A received a hello. Let's just clear some things up. So let's get rid of that default port, and let's explicitly receive a port here. Let's also get rid of that gentcp.send, and in our worker we can also clear the shrug guy. So let's just output whatever we receive and go back to our gossip server, gossip module, sorry. Okay, here we are. Before we go on, there are some things that we need to clear up. In terms of architecture, we're all over the place. We're connecting to new nodes here, and we're outputting here, but our input comes from the workers. Ideally, all the input and output logic would be in the workers. And we also added some weird bugs. So let's just do okay, node A, and do that start link on port 3000. Do the same for node B, 3001, and we need to connect them together. So node B connect to node A. Now we can broadcast from node B to node A. Let's do hello, and node A received a hello, but the opposite doesn't happen, and this is because new connections are handled in our server module here, and we never call our gossip process in any way to tell it to update our neighbors list. So that's what we're going to do. We're going to update our neighbors list, and then we're going to move the logic of writing to the output socket into our worker module. We'll do that by first defining an accept function. So we'll receive a PID and a socket, do genServer.cast again, pass it along. Now let's do handle cast, pattern match on accept, receive that socket, and our state. Now the code for this is pretty much this one. We're going to need to do a small change. Instead of OK, it's no reply. And instead of saving a socket, let's just save a worker and get that worker from a start worker function. Now we're updating our neighbors list to be the worker PID instead of the socket. We need to define our start worker function, which receives a socket, and we're going to get that from our server. So the code is this one. We need to do OK PID here. And we need to update here. So OK PID will equal start worker, give it the socket. Now we need to call the accept function, and it will happen here because we will do gossip.accept, give it the gossip PID, and give it the socket. We'll still need to get this PID from somewhere, so let's receive it as an argument and pass it as an argument here, pass it as another argument here, and there. Okay, so now it's an argument to the run function. Let's update our initializer. There we go. There's a small issue here because when we receive this socket, it's going to go through that accept function. It's going to go down here. We're going to pass it along to our start worker, and we're going to give it control. But the control does not belong to the gossip process. It belongs to the server process. And we need to do genTCP.controlling process socket gossip first before doing that. Now that we own that socket, we can pass it along to our worker. There's also a small change that we need to do here. Now we're assuming that our neighbors are sockets, which isn't true anymore. They're actually worker PIDs. So instead of doing genTCP.send, let's do a small change. Let's just call send and send in a tuple to our worker. Opening up the worker here, we're going to need to pattern match on send, and whenever we receive a send message, let's write it to our socket and return true to continue looping. Now we need to remove this active false from here, because if we kept active false, then this socket would be running on passive mode, and we would be passing passive mode socket to our worker, which is supposed to be running with active sockets. So let's just remove that, provide the default options, and leave it to be. Let's call IEX, no warnings, which is good. And let's do what we did before. So node A, node B, connect them together. This is good. And then do our broadcast from node B, say hello. And node A received hello. And now let's do the same for node A, and node B received hello. Okay, so everything seems to be working right now. Our next step will be to broadcast to our neighbors. And to do that, whenever we receive a message in our worker, let's open it up again. We will need to call gossip.receive, give it the gossip PID and the content. Let's put this as an argument to the receive loop. So add here gossip, and also in our recursive call, so gossip again. And before we forget, let's call self here. Now, the next step will be to define our receive function. Let's do that here. Let's also do a cast. And let's go down here to define it. So for each of our neighbors, we're going to do what we did before right here. I'm actually going to put this in a do broadcast function, which receives a list of neighbors, and put it here, list of neighbors, and the corresponding message. So now on our receive call, let's just do broadcast state.neighbors message. I'm actually going to switch the order of the arguments. It feels more natural to have the message as the first argument, and we'll probably have a better use for it that way. So whenever we receive a broadcast, we also want to do broadcast message neighbors. Okay, we're missing no reply state, and this should be ready for testing. Let's start node A, start node B, connect them together, and now we're looping. We're looping because node A's neighbor is node B and node B's neighbor is node A, so they're basically playing a ping pong game with no end. So we need to add a different module that is going to keep track of the messages that we have already received and generate unique IDs for any new message. This new module will be called Messenger, and it will be a wrapper run agent. So let's open it up and do def module gossip messenger. Now, we need to define a format for our messages, or for the IDs of our messages. Each node will have a messenger process that will have a UID, and it will be added an ID, an incremental ID for each message, so we can know if we have received repeated messages or not. Let's start by doing start link, and just do agent.startLink. Give it a function. Oops, okay, here we are. So the initial ID will be 1. We're going to give it a UID, and we're going to give it an empty list of messages to keep track of. Now, this is going to come from the UID package. So let's open our mix.exs and add UID. Let's use version 1.1, run mix steps get. Okay, there it is. Now, this is our start link function. Next up, we're going to define a pack, which receives the PID of our messenger, and it receives a certain content. First thing we will do is to retrieve the current UID and the current ID through agent.get and update. Now we're going to give it our PID, get that map back, and let's just return map.UID, map.ID, and update our existing map. So it should have map.id +1 to be the new ID. And this will give us an update, the ID. Now we can just return a packed message, which will be a map containing the UID and the ID grouped together, as well as the actual content. We need to define the unpack, and we can do that by pattern matching. And we can pattern match on the ID and the content. Now, I'm going to do a small trick. Just going to pattern match here and get the current state. So I'm just going to get that map again. Here's the trick. If we have, if the ID starts with our UID, it means that it's our own message. So let's just return nil. And if not, if it's a member of our message list, we're going to return nil as well. And finally, if it's true, so if there's no other condition, let's just update our agent, pass it the PID. And this is a simple update to our list of messages. So mapset.put map.message, actually you can just do messages and message ID, and then return the updated map. So messages, new messages, and return the content. Right, so this is our messenger, and we can test it by doing okay, PID equals gossip.messenger.start link. Now let's just pack a simple message. So gossip.messenger.pack. Let's do that PID first and say hello. Okay, we got a packed message. Let's try to unpack it. And forgot the PID. There we go, we got nil. Now let's try a different message by changing the UUID. So let's just copy that and change this from 4 to 5. This should be a new message. So let's try to unpack it. We get hello, and now let's unpack it again, and we get nil because it's a repeated message now. Let's add this to our gossip process. So I'll start by adding an alias here. Now on our init function, we need to save our messenger. So let's do that messenger, let's start a link and save it here. Let's go to our receive function first and do this unpacked message equals messenger.unpack, give it our state.messenger, and give it our message. So unless our unpack message is nil, let's broadcast. And we need to pack our message before writing to it. So in our do broadcast function, let's do packed message equals messenger dot, actually instead of doing it in our do broadcast, because if we did on our do broadcast, need to pass the messenger here. I'm going to do it in our broadcast. Okay. Our message will actually be messenger.pack and state.messenger message. And we can actually change this to state.messenger, pipe it to messenger.pack message, and pipe that to broadcast neighbors. Okay, I think this is pretty much it. So notice how we're broadcasting the packed message to our neighbors. So we received it, and instead of repacking it, we're sending the original message. If we called pack again, we would be updating the message ID, and it meant that we would be perpetuating that message across the network. So let's test this in the previous case. I'm going to start node A, then node B, just going to do connect to here and do that broadcast. And you will notice that there's a bad value output. This is because we're attempting to write maps, and our sockets only support binaries. So we need to pack that map into a binary. Instead of doing everything by ourselves, let's have a bit of fun and add a message pack library. So let's add message packs and do mix deps get. Okay, here we go. Now we need to update our messenger. So let's change this to make use of msgpack. And this pack function returns OK packed message or error otherwise. But since we are the ones producing content, we can use the pack with a bang that returns the packed message or throws an error. So let's just do that, but also add a bang here, just to give ourselves a little warning. And we'll define a new unpack function that receives the same arguments, but calls msgpacks.unpackMessage. Now if it's OK unpacked message, we're going to do unpack and give it the process ID and the unpacked message. If it's something else, let's just return nil. Now we need to make this private and rename it to do unpack. Oops. Okay. Next step will be to update our gossip process to make use of the new pack function. And we also need to go to our worker and take this io.putAs call, because it's pretty much gibberish at this point. It's a packed message. Instead, let's just do the message, the output here when we have unpacked it. So unpacked message. Now let's launch IEX, do node A, start node B, connect them, and do that broadcast. And here we go. Let's do the broadcast from node A, and we have output the same. So now only one thing is missing. This is supposed to be a middleware, and we're going to need a couple of things, which is to define a port and a callback. Right now, whenever we receive a new message, we are doing io.puts all the time, and we actually want to do state.callback and give it the unpacked message. Now this is going to be an argument to the init function, which is here, and we're going to need to save that into our state. Now the formatter hopefully will run. Here it is. And we should have the API that we want. So let's close everything. Open IX. Okay, so small error. Gossip 35. Here it is. I forgot to do this parent match here. Call back. Here we go. And let's try what we did last time. So node A, no, the API changed. So port 3000, callback. Let's do io.inspect. Let's start node B the same. And let's start a node C as well. And let's do the same that we did in our demo in our first example. So gossip.connect to, let's connect node B to A, and let's connect node C to A. And now let's broadcast hello from node B. And we got two outputs. Instead of broadcasting hello, let's just broadcast a map. And here we go. Notice how message packs converted the atoms to strings. So that was the issue why we had to change our function in our messenger. Okay, that was it. I hope you enjoyed it. You're going to probably wonder why we didn't do tests and why I was testing everything manually. It's mostly because that's going to be the subject of the next episode, how we test this, knowing that we have all these nodes and asynchronous processes running. So thank you for watching.